Okay, so we're going to do some very simple first day balancing equations, all right? And the first thing that we do when we balance an equation is try to label the type of equation. So let me write an equation here. How about this? Potassium plus chlorine gas, that's Cl2, makes potassium chloride. Now this is something that would really happen, okay? All right. Now the thing about this chemical reaction is it obviously can't exist because there are two chlorines here, and after the reaction there's only one chlorine. So that breaks the law of conservation of matter. And the fact is there are trillions and trillions of potassium atoms around and trillions of chlorine molecules around. So it takes odd numbers of each, or specific numbers of each, to actually make an equation happen. So what we're going to do is just balance this, all right? Now we can look at our potassiums first. There's one potassium here, and there's one potassium here. So those are good. But there's two chlorines here, and there's only one chlorine here. So we need to bring this chlorine up to 2. Now I can't write a little 2 here. You can't do that. Because A, KCl2 is not even a real formula. B, we're producing potassium chloride. So if we're trying to change this chlorine and bring it up to number 2, we can only add a number in front of the whole compound. And this number is called a coefficient. So now I have 2 chlorines. But look what it did. It changed my number of potassium atoms. So now I've got to go back over here and I've got to fix it. What number am I going to need here? That's right. I'm going to need a 2. So now we can take another look at the equation. We can be 2 potassiums and chlorine gas make 2 potassium chlorides. 2 Ks, 2 Ks, 2 Cls, 2 Cls. It's balanced. What we try to do is put a 1 in any empty blank we have. And if I said, hey, what's the answer to this? You just say 2, 1, 2. Okay? Let's try another one. So that's about as easy as they get. I'm going to try one that's just a tiny, tiny bit harder. Okay? Not much harder. Literally just a very, very little bit harder. Now that equation that we saw right there, that was a synthesis reaction, right? Tell me what type of reaction this one is. We're going to take some sodium and we're going to put it around some magnesium oxide, okay? And we're going to have that make sodium oxide, and the formula for sodium oxide has to be Na2O, because that's an ionic equation. It's got to be equal to 0. And it's going to kick magnesium out. Magnesium is going to be by itself. Now this one probably wouldn't really happen, but we're going to balance it, okay? What type of reaction would this be? The sodium is by itself. That's right. Magnesium's with his girlfriend. And then something happens, and now sodium's with oxygen, and magnesium's by itself. That's called a single replacement reaction. Magnesium was replaced by sodium in the compound, okay? So first of all, that's a SR, single replacement. Now let's balance it. I've got one sodium here, but over here I have how many sodiums? 2. So I'm going to go ahead and add a coefficient here and say, okay, I've got 2 sodiums and I've got 2 sodiums, right? Let's take a look at our magnesiums. There's one magnesium here, and over here there's one magnesium, so that's good. And then there's one oxygen here and one oxygen here. We're done. Fill in your blanks with 1. And 2 sodiums and 1 magnesium oxide make 1 sodium oxide and 1 magnesium. That's it. It's done. Some of them are very, very simple to balance. And let's do one more. Let's do one more. This last one is going to be a different type of reaction. We're going to have some lithium carbonate, Li2CO3. And we're going to mix that with some calcium chloride. And that reaction is going to produce lithium chloride and calcium carbonate. Make sure that's on the screen there. It is. Okay. So, what type of reaction do you think this is? It is. It's a double replacement. Lithium was with carbonate, and now lithium's with chlorine. And calcium was with chlorine, but after the reaction, calcium's now with carbonate. That's a double replacement reaction, and this one would happen. Okay. Let's try to balance it. How many lithium atoms are here? 2. So I'm going to put a 2 right here. Now let's take a look at, and that gives me 2 lithiums. Look what that also gives me. It gives me 2 chlorines, doesn't it? How many chlorines are on this side? So those are good. Let's look at this carbonate. I don't want you to think of carbonate as a carbon and 3 oxygens. I want you to just think of it as carbonate, CO3. Think of that as one thing. So I've got 1 carbonate here. There's not 3 of them. CO3 is carbonate, right? 1 carbonate here. How many carbonates are here? So that's good. And 1 calcium and 1 calcium. We're good. 1, 1, 2, 1. That's some easy balancing. And that's it. That's all there is to balancing equations. So the sheet that you have today and the first sheets are going to be basically no harder than this.